Welcome back to Hot Rod High School. In today's episode, we are going to be doing a battery and charging system inspection on this Subaru. So, coveralls on, safety glasses on, let's go to work. Doing this job is a lot like when you go to the doctor. Doesn't matter what you go in there for, they're going to be checking your weight, going to be checking your blood pressure. That's what we're doing here. It's not really a diagnostic test. It's more so just to get a baseline, how healthy is the electrical system on this vehicle. Let's get started. Our first portion of our test here is the OTC battery test. Just a quick and dirty approach, taking a look at how healthy is our battery for this vehicle. So the first thing we're going to do is the OTC battery test. Just a quick read on the condition of the battery. Hook up our two terminals. So, we took a look at the top of the battery, which told us the cold cranking amp rating for this battery, which is at 650. So we'll just hit the up arrow until it goes up to 650. And now we'll hit test. The cold test button is for if you're in like really cold temperatures. It's nice and warm in here. So we're just going to hit the regular test button. And it passes the test, so we could note that down on our sheet. Next, we hit any of the buttons to continue. I'll just hit the test button again. Now it's displaying our battery voltage. So this is how much voltage is available in our battery right now. And then any button to continue. And this is going to show us how many cold cranking amps are actually available in this battery. And we're at 875. This battery's recently been charged, and we're also in a nice warm environment in here, which allows it to be a little bit higher. So next up, it wants us to take a look at the positive and negative battery cable connection. Are they good? Are they dirty? Are they loose? Do they need to be replaced? Circle any and all that apply. So they're not loose, but I do note here that this cap that's supposed to go over our positive battery terminal doesn't fit. That's because this battery is not the correct one for this vehicle. It's too large. So I'd like to see getting the proper battery in this car, but if the customer refuses to, then this is pretty much what we have to work with. So our next portion here is doing our starter motor testing, and we are going to be taking a look at the voltage drop from the battery positive to the starter post. This is going to tell us if we have any problems in our starter motor, our battery cables, or even something like I've seen it where we have a seized air conditioning, air compressor, and that will actually cause a high value on this reading. So just making sure that we got a good look at it here. We're going to open up our fuse panel, and then this thing tells us what all these various fuses do. And if we look down here in the corner, we see a 15 amp fuel pump fuse. And so we're going to remove that fuse because we don't want the engine to actually start while we're doing this. We want to be able to crank over the starter motor and test it out. So here's that 15 amp fuse. Oop. We pull it out and we drop it. We'll retrieve that later. Our starter motor for this car is right up top. We're going to pull off this rubber boot. So it looks like that. And we will, wrong terminal. It can work either way, but it'll have a negative sign on it if you hook it up that way. So just take and hook that up onto that positive starter terminal. I'm also going to hook this up onto the positive at the battery. If I'm doing this test alone, I would take this and slide it up here. That way I can read the meter from inside the vehicle. But since we want a good view for the camera, we'll just leave it right here. I set this to DC volts, and now I'm going to crank the engine over, making sure not to crank it for more than 15 seconds, and then we'll see what our voltage drop reading is. The note on our paper states that it needs to be below 0.5 volts at all times. So we jumped up as high as a 0.4 initially, then it leveled out under 0.2, which we're just fine with here. So we got a good condition on our battery positive side. That's just telling us that we got low voltage drop. We don't really have any problems to worry about right there. If we had something else, then we'd be talking to the customer, asking them if they want us to go into a deeper dive on what the problem is, what the issues are. Next, we need to do a voltage drop from the battery negative to the engine block. So same test as this, except for we're going to be going over to the engine block over there, and we'll be over at the battery negative. So we'll just move our negative terminal here onto our battery. And then our other terminal here, I'm going to put it over onto these ground connections. So just wedge it into where these ground connections are right here, and this should give us kind of a perfect vantage point to see how healthy the ground side is on our battery. So during that test, we did find that the readings were a little bit higher than we want to see, a little bit above specification. And taking a look at this negative battery terminal, we can see corrosion inside the terminal itself. And that's a pretty clear example of what we could find there. These kind of things can cause what a lot of people would call like electrical gremlins, little problems inside the systems. And maybe you're going to have a hard time getting the car to start like on a cold day. Or maybe it's, and I've seen people go, oh, well, I've changed out the alternator, I've changed out the battery, I've changed out the starter motor, and it still has the same problem. Did you diagnose any of it? Did you run any tests? Nope, just been replacing parts randomly. You can replace all those parts on this thing, and if you don't replace this negative battery cable, the condition's not going to get better. So save yourself some money, do the test first, prove what your problem is before you go spending money just replacing random objects. Okay, our next portion to do here is our starter motor draw test. So we're going to need to easy hookup on this. We're going to leave this on DC volts. The positive goes on the positive side, the negative over on the negative side. And we're seeing that no load voltage 12.66 is what we're sitting at. And then we also want to know what is our amperage. So I'm going to take out this little meter right here, which can do voltage as well. I prefer this one. But anyway, we can go click that over to amperage DC, and then we're going to hook this around the positive battery cable, making sure to go around the cable that goes down to the starter motor there. I'm going to zero this out with it not hooked up to anything, just hitting that 0 button. And then we can hook this up around that positive wire right there. So now that we have this setup done, we can crank the engine over, and we're going to see how low does our voltage go down to, how high does our amperage go up to. So both of our readings were in the acceptable range. That's what we want to see. The note on your paper there says if the voltage drops below 9.6 during the test, the battery needs to be recharged or replaced. It stayed well above that during the test, so we're looking just fine right there. Next up, we need to do our parasitic draw test, which technically we kind of already been doing. I want to get around the entirety of this battery cable and see what reading we get there. And we're getting a reading of 0.1. So that's how much amperage this car is using with no key sitting in the ignition, nothing else like that. And so we can put down that we are below that 200 millivolts, that 0.2 volts on our parasitic draw, so that looks good. So at anything over 0.2, the battery might drain too quickly just with, it could be any little thing. Maybe the light bulb in the glove box isn't turning off, something like that. That might not drain your battery immediately, but maybe over the weekend you come out and your car won't start with a dead battery. So we want to do that test just to make sure, is it draining too quickly or is it at that modest amount? That little bit that we're seeing, that 0.1, is running like the vehicle's computer, the little clock that's in there, those kind of things. Just a tiny trickle of electricity coming out. Next, we're looking at our belt condition, checking for any signs of wear, any cracks, anything like that. Are they loose? When you're cranking it over and when starting it, is it making any kind of a squealing sound? These ones look to be okay. Next, we gotta look at our battery hold down condition, and we see that our battery hold down is missing. So we would note that down on our paper here. And next up, we can do our alternator testing. We're going to find engine running AC voltage. An alternator does produce alternating current, and it goes through a rectifier that turns that over into DC current. So if we see too much AC current coming out of our alternator, it's telling us that the diodes are bad. And in bad conditions, we can actually see the headlights start to flicker with the poor diodes in the alternator. Things like that can end up happening. It can cause problems in the vehicle's computer system because it's made to run on DC electricity, not have that AC current coming into it. So we'll take a look at that with the engine running, what our AC voltage is, and that's going to tell us if our diode pattern is good or bad. So I went and found that fuse that we dropped from earlier. We're going to plug that back in to the fuel pump outlet here. And that's going to allow us to start our vehicle up because we do need it running for the alternator test. For this, we also need to plug in our exhaust vent, make sure that we're not filling up the shop with bad smoke and all that. So because we're trying to detect AC voltage, we'll flip this guy down right here, and we're just going to put the positive over onto the positive post, negative over on the negative post, and we'll start the vehicle up and see what our reading is. So we saw a reading somewhere around about 22 millivolts, way lower than 50, exactly what we wanted to see from a good operating alternator. Next, we're going to do our alternator output, getting our voltage and our amperage. Have this guy hooked up around our main cable here, and we'll put it up to DC amps. We'll switch our voltmeter back over to DC volts. Then we'll start the engine up, and I'm also going to turn on like the wiper blades and the headlights, and put a little bit of a load on this thing, see what our amperage goes up to. Go for it. So now we've taken down our voltage and our amperage coming out of our alternator. Everything's been looking pretty good on this one. So now we have done our broad overview, our quick diagnostic check to see how everything is on this electrical system. This is just any kind of electrical complaint that comes in. We're going to go through and do this series of tests so we have our baseline measurements before we get in and start trying to do diagnostics. I don't want to be replacing alternators and starter motors and stuff if I've already found out that we have a battery cable that needs to be replaced. So I'm going through and I'm doing this before I do any deep dive into any of the subsystems to see what might be going wrong with them. Thanks for watching. Thanks for watching another episode of Hot Rod High School. If your school doesn't offer an auto shop class or you're a homeschooler, we've got the thing for you. That's right, introducing our first ever Auto Shop in a Box. Specifically designed for students between 5th and 12th grade. Our kits include the engine rebuild, the brake line flare, precision measurement, valve adjustment, and an award-winning curriculum. Click the link in the description below to learn more on our website and purchase your kit today, which will be shipped directly to your home. But don't worry, it's not coming in this thing. You can like and subscribe if you want to. It doesn't make a difference to me. But what does make a difference is you shifting your education into high gear with Hot Rod High School. Thanks for watching.